Okay, so now what we're going to talk about is something called dimensional analysis. And you may have seen this before in another class. It is an important skill. A lot of the stuff we're going to do in chemistry involves the process of a dimensional analysis. So I'm going to start off easy. We're going to scaffold it a little bit for you guys. Something you already know how to do, something that you've already figured out, and it's using the units to solve problems. Okay, so for example, many of the problems that you encounter in chemistry are going to have this dimensional analysis going on. I'm going to start simple. So how tall is 6 feet in inches? So that's how tall I am. So if I wanted to find out how tall I am in inches, I know you know how to use a calculator and figure this out. I know that. Okay, or you can even do it without a calculator if you remember your times tables. But I want to show you the process with something simple that you already understand so that you can use that process when you run into something you won't understand. Okay, so what you're going to do is you're going to use something called a conversion factor to change the units. And we all know 1 foot is 12 inches, or at least if you were born in the United States, you know that. And these units are equivalent to each other. They're what's called a conversion factor. They're the same thing. By definition, there are 12 inches in 1 foot. It's not 13, it's not 11. Okay, and we're going to set it up as a fraction where either 12 inches is over 1 foot or 1 foot is over 12 inches, because when those, I guess, divide, because they're equal to each other, they're equal to 1. And those are called conversion factors. They're fractions. And that's what we're going to use to do dimensional analysis with. Basically, what you're going to do is you're going to multiply by the one that will give you the correct units in your answer. So let me show you how this is done. In chemistry, this is something you're just going to have to get in the habit of doing. You start by always writing down the number and the unit I give you. Okay? It is okay to abbreviate. Sig figs I would keep. So 6.0 feet, and you're going to multiply by one of these conversion factors to get rid of the word foot and convert into the word inches. So the way it's going to work just like in math class. If foot is what you start with, then it's going to go on the bottom to cancel out. Just like if you had 9 times 4 over 9, the 9's cancel out. It's the same idea. So feet will cancel out, and you want to put the thing that you were trying to get to. It goes in the numerator. Miss Ellis is going to emphasize this a lot. Inches is what I'm trying to go for. It's what I'm trying to solve for. It goes in the numerator, and then you're going to put inside here the numbers you know for the conversion factor. And in that case, 1 foot is 12 inches. And so when you're doing a conversion, the way it works is the numbers on top of the fraction all multiply, and the numbers in the bottom divide into it, 72 inches. Okay, so I realize that's a long process for something you already know how to do. Okay? So the steps to solve the DA problems. Identify the number and the unit you wish to change. So you have to be able to look at a problem and pull out this crucial information, read the problem properly, and pull out what you're going to start with. You're going to set up the conversions so that the unit you want to get rid of, the one you're starting with, is going to cancel out. So if it's on the top, it goes on the bottom of the fraction, and it will convert to the one you want. In the numerator, that's where you're going to put the one you want. Okay, and you're going to, this is my little clue, do the letters before you do the numbers. Okay, the numbers, people are very anxious to solve these problems. They want to do it, and they want to do it right, and but they're like in such a freaking hurry. They write the numbers down first. Write the letters first, because that sets, it's like a map. It tells you where to put the numbers. Okay? And then you put the correct conversion factors in. That would be the numbers for each unit, and multiply or divide as needed. So, this is conversions within the English system. I realize it doesn't make a whole lot of sense to you, because it doesn't make a whole lot of sense to anyone, actually. Metric system is significantly better, but for right now, we're going to deal with stuff that you're familiar with. So 1 foot, 12 inches, 3 feet, 1 yard, 5,280 feet, 1 mile. A pound is 16 ounces, 2,000 pounds is a ton, and a cup is 8 fluid ounces. 2 cups is a pint, 2 pints is a quart, 4 quarts is a gallon. Makes no sense at all, but it is what it is. Okay, so we're going to go through some sample problems. So 8.65 years to seconds. So you start by writing down the number and the unit that I give you in the problem, and you want to convert it into seconds. Now, you probably don't know off the top of your head how many seconds are in a year. So what you want to do is you want to get rid of the unit you want by putting it in the denominator to cancel out, and you want to convert it to something that you do know about years and put that in the numerator. Now, you could pick months, but months is a little tricky. It's better to pick days. Okay, so I put my letters in first, then I put the numbers in, and I know that 1 year is 365 days. Years cancels out. If I was to stop right now and multiply those two numbers on the top and divide by 1, I know how many days I'm dealing with. But here's the cool thing about conversion factors. You don't have to stop. You can keep going. So I'm going to put days, which is now in the numerator, into the denominator, so it cancels out. And I'm going to put something in the numerator that I want that is getting me closer to seconds. Now, I may not know how many seconds are in a day, but I do know there are 24 hours in one day. And we're assuming there's no leap years here. Okay? And so now, if I was to stop right now and multiply all this through, all my units have canceled out except hours, and I would know how many hours are in 8.65 years. Well, I don't want to do that. I want to take it one more step. I want to put hour in the denominator so it cancels out. And in the numerator, I want to put something that I want that is getting me closer to seconds. Maybe you know how many seconds there are in an hour. Wouldn't surprise me, but I'm just going to put minutes because I do know that. And 1 hour is 60 minutes. Hours cancels out. And now I'm going to put minutes in the denominator to cancel out. And now I can do my seconds. 1 minute, 60 seconds. So I have a very long multiplication problem here. But calculators are a good thing. You go through, you multiply all those numbers. And you get a really, really big number. 272,786,400 seconds. Now, does that make sense? That's another thing. You want to ask yourself, does that make sense? Would I have, what is this, 272 million seconds in 8 years? Probably that's not an unreasonable answer. Okay, I do need to put it in sig figs. This has 3, and these guys are all by definition. Since they're all by definition, 3 is what I'm going to go with. So 273,000,000. All those turn into zeros. Or you can put it in scientific notation. But make sure you include units, because I am really a stickler for units. All right, so now I'm going to erase what I've got on the slide. We're going to try this one, okay? Starting with seconds this time. So 6.9 e to the third seconds to start with. I'll put seconds on the bottom in the denominator to cancel out, and something that I want in the numerator. Well, I'm going to go straight to hours, because I know 1 hour is 3,600 seconds. Seconds cancels out. Hours goes in the denominator to cancel out. Now I'm going to do days. 24 hours, 1 day. And then I'm going to put days in the bottom to cancel out. And I'll put years on top. 1 year, 365 days. So you may notice that this is the term is reciprocal from the previous problem. In other words, all the numbers that were on top before are now on the bottom. Okay? That's okay, because I put the words in first, then I put the numbers in, because the words tell me where the numbers go. Okay? So you would not want to write 6.9 e to the third seconds, and then go seconds. And let's say you went to minutes. You put 60 minutes, 1 second. Does that make sense? What you're telling me is that in 1 second, there are 60 minutes. That is not a correct conversion. That's why it's important to put your words in first, then put the numbers in. Don't just get in the habit of always doing the numbers. Okay? Now to solve this one, you're going to divide. I think personally it's just easier to just hit divide, 3,600. Hit divide again. 24. Divide, 365. And you get a really small number, 2.18. Let's do sig figs. Right here there's 2, and these are all by definition. 2.2 e to the negative 4 years. Okay, and again, that makes sense. It's not a whole lot of years. It's only 6,000 seconds. couple of minutes. All right, 16 gallons to ounces. So 16 gallons. Look back at your conversions. You do not have to memorize those. I will give them to you. I do kind of expect you to know time. Okay, the rest of them I don't care about. So gallons, 1 gallon is 4 quarts, because I don't know how many ounces are in a gallon. Then I'm going to put quarts on the bottom. And if I look back at that chart, I know that there are 2 pints in 1 quart. And in 1 pint, there are 8 cups, or 1 pint, 2 cups. And then cups on the bottom, ounces on top, 8 ounces, 1 cup. And so you're going to go through and you're going to multiply all those numbers and have an answer with 2 sig figs. Because again, anytime you're doing a conversion with a known, by definition, quantity, you don't count them for sig figs. So for this one, not a great choice, but it's 2,048 ounces. Correct number sig figs should be 2. So that'd be 2,000, but I can't do that as scientific notation or as sig figs unless I put it in scientific notation. So 2.0 e to the third ounces. Okay, this one 1.71 miles. And again, look back at that chart. Miles in the bottom to cancel out, and I would just go straight to feet. You can go to yards if you want, you know. But 1 mile is 5,280 feet. Miles cancel out. Feet on the bottom, inches on top. 1 foot, 12 inches. And you're multiplying. And you get 108,345. This has 3 sig figs, so we're going to call it 108,000 inches. Okay? So the way you do this every time is do the words first. Whatever you start with words, you put it on the bottom in the denominator to cancel out, and you put something on the top that you can change to that's heading you in the direction of the correct unit. Okay, now these are a little bit harder. 1.35 times 10 squared, or sorry, yeah, 100 times 10 squared square feet. So 1.35 e to the 2, and I'm going to write it this way, feet squared. Okay, notice I wrote it that way there as well. And so just like before, I'm going to put feet on the bottom. Notice I did not call it feet squared, and I'll explain why in a minute. Okay, if you look at the conversions on the chart that I gave you, I don't have anything that talks about how many feet squared and inches squared, what the relationship is there. All I have is I have a relationship between feet and inches. So I can't call it feet squared and inches squared. I have to call it feet and inches. But because this is squared, what that means is I'm going to repeat the exact same process twice, because feet times feet is feet squared, just like x times x is x squared. So this and this now cancel out, and when I multiply these together, and again, watch your sig figs. Okay, I need to have 3 sig figs, so 19400, and the units are inches times inches, inches squared. Okay, so that's how you deal with things that are squared. You do it twice. It makes it a lot easier. Okay, if you had feet cubed, think about it for a second. If feet squared to inches squared, I do the conversion twice. If I'm looking feet cubed to yard cubed, I do the conversion 3 times. But it's done exactly the same way. So 37.5 feet cubed. Feet on the bottom. I want to get rid of the feet, and I want to change it to yards on top. And look at my conversions. 1 yard, 3 feet. Because this is cubed, I am going to repeat the exact same thing. I'm not setting it upside down or anything. It is exactly the same each and every time. So 37.5 divided by 3 divided by 3 divided by 3 is 1.38888888. 3 sig figs, so 1.39 yards cubed. Now this one's a little bit trickier. 55 miles per hour. So I'm going to write it this way. See how I wrote it this way for you? That usually makes your life a lot easier. Miles per hour. And I want to end up with feet per second. So what I'm going to do is I'm going to take them one at a time. Miles to feet. I'm going to ignore the seconds and the hours. I'm just absolutely going to ignore them, pretend they're not there. So all I'm looking at is miles on the bottom, because it's on the numerator here. I need to put it in the denominator here to cancel out, and put it into feet on top, because I want feet on top. 1 mile, 5,280 feet. Miles cancels out. And if I was to stop right now, my unit on top would be feet, and my unit in the denominator on the bottom would be hours. Well, I don't want feet per hour. I want feet per second. So I'm going to take it one more step. And I'm going to take the hour, which is in the denominator now. In order to get rid of it, it has to go on the opposite side of the fraction. It's on the bottom here. It goes on the top to make it go away. So hour, and maybe you know how many seconds, but let's just say you don't. Let's say minutes. 1 hour, 60 minutes. Hours cancels out. If I was to stop right now, multiply 55 times 5,280 divided by 60, my answer would be whatever it is in feet per minute, not feet per second. So I'm going to take it one more step. Minutes is on the bottom. To cancel out, I'm going to put it on top. Seconds on the bottom. 1 minute, 60 seconds. Minutes cancels out. And so now you've got a multiplying and a divide problem. And my calculator says 80.666666. 2 sig figs, we're going to call it 81 feet per second, because I'm keeping those units exactly as they are. It's really important to pay attention to what you're doing.